Exercise 8.2, roots and radicals. Starting with some definitions again. Square root. Square root is asking what number can be multiplied by itself to equal a given number. An index is not given on the radical. So if you see something like the square root of 16, what number times itself equals 16? We know the square root of 16 is equal to 4 because 4 times 4 equals 16. Cube root. What number can be multiplied by itself 3 times to equal a given number? The index is 3. So in this case, if I have the cube root of 8 is 2 because 2 times 2 times 2 equals 8. Index on a square root is not given. Index on a cube root is given right there. If there is no index given, as is there, the index is understood to be 2, meaning that it is a square root. The index indicates what root you are taking. Okay, so indexes are important because otherwise you don't know what root you're taking. Most of the time we work with square roots, so there is not an index given, but it's understood to be an index of 2, indicating that it's a square root. Those are the 3 parts of a radical expression. The index is a small number located inside the square root here, or on the outside of the square root, I should say. The radical is what many people refer to as the square root symbol, which isn't the case unless if you're taking a square root. And the stuff underneath the radical is called the radicand. Okay, so the index, radical symbol, and radicand is the stuff underneath. If there is no index given, it's understood to be a square root. In order to simplify square roots, you need to be familiar with some perfect squares. That is the easiest way of simplifying radicals. If you don't know these square roots, you have to make factor trees every single time you're going to break down radicals, which is very, very time consuming, which is time that can be better spent on a time test like the ACT rather than making factor trees. Simply know some of these perfect squares. So here's a list of the first 13 perfect squares. These are the only numbers 169, 144, 121, 181, up through 169 that work out to be a nice integer value when you take the square root. Okay, so you need to know that 13 squared is 169, 12 squared is 144, 11 squared is 121. Most people probably already know up through 10, know those next 3. Usually you're not going to get anything larger than those on an ACT test. The reason these are important to know, if you get something like the square root of 18, they're not going to leave your multiple choice solution equal to that on an ACT test. The way you would break this down is you would look for which one of these numbers out of our list are factors of 18. What number divides evenly into 18? 9. 18 is 9 times 2. What's the square root of 9 now? Well, that's just 3. You're left inside the radical with a 2. So that's how we would break down root 18, and that's how you would see that answer written on an ACT. There's other ways that we're going to talk about where if you can't break these down, it should not be a reason to get the problem wrong because you should be able to get decimals and match things up, but this is going to be the quickest way of getting to solutions. We can do the same thing with perfect cubes. Perfect cubes don't come up quite as often. You don't need to memorize as many perfect cubes because the numbers get very large very quickly. But here are the first 5 perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed 27, 4 cubed 64, 5 cubed 125. And again, anything larger than that usually is not going to be given on an ACT test. So looking at a couple of problems here. If a number is not a perfect square, it's more difficult to simplify the radical. You must look for perfect squares that are factors of the given number. So just like when we did root 18, we recognized that root 18 was 9 times 2. Square root of 9 is 3, and we're left inside with 2. We're going to be doing the same type of things here with these. So looking at the first one, root 32. Root 32, we want to go back to our list of perfect squares, and we want to pick the biggest number that is a factor of 32. Well, obviously, we start right here at 25 because 36 is bigger than 32. Does 25 divide into 32? No. Does 16 divide into 32? Yes. 16 times 2 is 32. The square root of 16 is 4. We're left inside with 2. There's that radical in simplest form. Square root of 250. We're going to do the same thing. Go back to our perfect square list. 250. Which one of these numbers divide evenly into 250? Well, this time that's going to be 25. 25 times 10 equals 250. Square root of 25 is 5. Or left hand side with the 10. So 5 root 10 is the same thing as root 250. Root 54. Go back to your perfect square list. Root 54, what perfect square is a factor of 54? That is going to be 9. 9 times 6 is 54. Square root of 9 is 3. Left hand side, the radical with the 6, 3 root 6. Square root of 64. That one breaks down very nicely. Square root of 64, 8 times 8 is just 8.